Hello guys, how are you doing? Yes, this is your Dr. Mantara Shiva. In this video, we are going to cover the previous year questions of NEET from the laws of motion chapter. Okay, so this is the part one of the series. We'll have 2-3 more such sessions. Okay, so basically, if you're having any basic doubts on Newton laws of motion, I have given the link in the description below. You can go through it and get rid of your doubts. Okay, now let us get started with the previous year questions of NEET. The first and foremost question is talking about physical independence of force is a consequence of. So what is this actually means? Physical independence of force is nothing but, let us say, if you consider any mass which has, let us say, horizontal motion and vertical motion. So horizontal motion is independent of vertical motion and vertical motion is independent of horizontal motion. That's what is nothing but the physical independence of force. Okay, when the forces are not going to affect, horizontal force is not going to affect the vertical forces and the vertical forces are not going to affect horizontal forces. That's what it is. Okay, which is a consequence of dash. Okay, that is a first law of motion. How? Let us consider what is first law of motion, by the way. The body which is at rest or in uniform motion tends to be in the same state of motion is nothing but here, unless and until there is an external force acting on it. Okay, so what does it mean? F net on the system has to be equal to 0. Other way of saying it is the system has to be in equilibrium. Okay, so when you are applying this, you might have observed that if suppose there are 4 forces acting on this mass M, F1, F2, F3, F4. Okay, so when we see that along horizontal direction the net force has to become 0. F1 should be balancing F3 in this case and F2 should be balancing F4 in this case. That's when we can say that the system is in equilibrium. And now you can say that this is how this first law of motion is related to physical independence of force. Okay, so option C is correct. Alright, next question. The force F acting on a particle of mass M is indicated by force versus time graph. The change in momentum of the particle over the time interval from 0 to 8 seconds is as normal. By the way, what is the change in momentum? Change in momentum is nothing but it's nothing but a force into time, change in time. Okay, it is from the Newton's second law of motion. F is equal to rate of change of momentum. Alright, F is directly proportional to rate of change of momentum. Yes, delta B is equal to Bf into delta T. Now, if you find the area under the curve for this Ft graph, then you get area under Ft graph gives you the change in momentum. Isn't it clear? Because that is going to give you F into delta T. Alright, F into delta T. Okay, now let's find that out. So for that, let's maximize it, zoom it. Now here, one force is here if you see this area is actually nothing but area of a triangle. Area of a triangle is nothing but half into base into height. So yes, the change in momentum delta P is equal to half into base is what here, 2 units. Height is actually 6 units. Alright, next, so this guy is actually in the fourth quadrant. In the fourth quadrant, area will be negative. Okay, so here it's nothing but 2 into the time is actually 2 units and the force is actually changing by 3 units. That is negative here, minus 3, plus what is the area under this curve now? This is also a rectangle. What is the rectangle area? Base into height. What is the base here? 4. What is the height? 3 units. Okay, so 2 ones are 2 ones are 6, 2 threes are 6, plus 4 threes are 12. 6 and 6 gets cancelled. You get 12 Newtons second as the change in momentum. Alright, yes. Now let us see next question. A stone is dropped from a height h. It hits the ground with a certain momentum p. If the same stone is dropped from a height 100% more than the previous height, the momentum when it hits the ground will be changing by. So you have to find the percentage change in momentum. Okay. So first of all, let us say the momentum when you are throwing the stone, when you are dropping the stone at a height h. Okay. So initially you are dropping, so u is equal to 0. Finally, it has to become, velocity has to become some v. You don't know what it is. And now momentum p is going to be mass times velocity. Now let us say that is p1, okay, and mass is same, so v1 now. And in the second case, you are actually increasing the height by one more time. That means 100% more. That means what? The height is supposed to be one more time extra. That means the height of the tower or something else can be h plus h, 2h. Okay. Now let us say in this case the momentum is p2. Say that is m into v2 because you are throwing the same stone. Okay. So here what is the velocity? If you find velocity here, then your job is done. And what about the velocity here? You need to find. So basically it's like a stone is dropping. It's going under motion under gravity problem. Okay. So here acceleration is going to be minus g. And what about s? S is actually minus h. So for motion under gravity problems, you can take acceleration is always minus g, and the particles which are coming down, you can take velocity and displacement as negative, and the particle which is going up, you can take the velocity and displacement as positive. That you know already, I guess. Now let's apply, since it is a constant acceleration, you can apply equations of motion. I want to find v, so I can take v square minus u square is equal to 2as, which is convenient for us here. What is v square? v1 square, u square 0, a minus g, s minus h. Okay, v1 square is equal to 2gh, v1 will be is equal to root 2gh. Okay, so now m into root 2gh, very good. What about here? Similarly, what has changed here? Only the height, no? So can I say v2 as nothing but root of 2g into, in the place of h you should get 2h. Can I write this as root 2 into root 2gh? Okay, let me write this as mv. Let me keep it as mv1 only, and let me write it as m into v2 is equal to root 2 into, this is v1 na? So p2 is nothing but root 2 m v1, and p1 is equal to mv1. Very good. Now he is asking about percentage change in the momentum. So there is nothing but final momentum minus initial momentum by the actual momentum or initial momentum into 100. What is p2 here? Root 2 mv1. What is p1? mv1 divided by mv1 into 100. Okay, it is nothing but if you take mv1 common, it will be getting cancelled out. You will get root 2 minus 1 into 100. What is root 2 here? 1.414 minus 1 is nothing but 0.414 into 100. Okay, so it is nothing but you just multiply with 100, then you get 41.4 percentage. That is the answer. But here you don't have 0.4, but it is actually most related to answer. So 41%. Next, a body under the action of a constant force, force F is equal to 6i cap minus 8j cap plus 10k cap acquires an acceleration of this much. Here he has given force, acceleration, and he is asking about mass. So what is the relation between these three? F is equal to ma. Alright, now you want mass. So for mass you can consider the magnitude of force divided by magnitude of acceleration. What is that? Magnitude of force now, that is equal to root of x component square 36, y component square 64, z component square 100 divided by, what is the acceleration here? 1. So now 36 plus 64 is nothing but 100, 100 plus 100, 200. So root 200 can be written as 10 root 2 by 1 is nothing but 10 root 2 only kg. That is the answer. Okay, 10 root 2 kg. Alright, next. A sand is being dropped on a conveyor belt at the rate of m kg per second. He has given dm by dt, the rate at which the sand is dropping. Okay, that is m kg per second. Very good. Now the force necessary to keep the belt moving with a constant velocity. Velocity has to be constant. That is a value we know. Okay, will be. Now, if you have not seen the conveyor belt, you can see it here. Generally, these conveyor belts are used to move the sand from one location to another location conveniently. Okay. Now, he is asking about how much force is necessary to keep the belt moving for maintaining that. So, if you consider Newton's second law of motion, F is equal to dp by dt. So, basically, P is nothing but momentum, mass times velocity. So, if you just apply this UV rule, so m dv by dt plus v dm by dt Here he said clearly that the velocity is a constant. Then that means when velocity is equal to 0, velocity differentiation should, when velocity is constant, velocity differentiation should be 0. F is equal to v dm by dt. He is asking about force only. What is v? Velocity is v only. Dm by dt is nothing but m kg per second. So answer is nothing but m times v newtons. Okay, option C is correct. Next, an object of mass 3 kg is at rest. Now a force of this much is applied on the object, then the velocity at t is equal to 3 seconds is. Now he is asking about velocity. So velocity generally is nothing but so find out from there. Let us take the given information. F is equal to 6t square I cap plus 4t j cap. Now you can find out acceleration from this, since you have got mass also. Mass is 3 kg. So what is acceleration? Acceleration is equal to 6t square by 3 I cap plus 4t by 3 j cap. Force is equal to, acceleration is equal to force by mass, isn't it? So 3 ones are 3 twos are, so that's why 2t square I cap plus 4t by 3 j cap. That's your acceleration. From acceleration we know clearly how to find velocity. Okay, so what is acceleration, by the way? Acceleration a is equal to rate of change of velocity. What is velocity here? dv will be is equal to a dt. If I want velocity, initially the system was at rest, so initial velocity is 0, final velocity is a v, and the time supposed to be, let us say initially at time t is equal to 0, the system has been started, and time t is equal to t, that is equal to 3 seconds here. Okay, what is a here? 2t square I cap 4t by 3 j cap integral dt. Okay, now you have to apply this integration for both the terms. So 2 into t, limits are from 0 to 3 seconds. Alright, 2 into t square is nothing but integration is nothing but t cube by 3 I cap plus 4 by 3 t square by 2 is the integration of t. Okay, along j cap, and the limits are from 0 to 3. Okay, so if you just take 3 and substitute it here, 2 into 3 cube is nothing but 27 by 3 9, 2 ones are 2 twos are, 3 square by 3 is nothing but 3, 2 into 3 j cap, so 2 nines are 2 threes are. Alright, that is the answer, option B. Clear? Next, a cricketer catches a ball of mass 150 grams in 0.1 seconds, moving with the speed of 20 meter per second. Then he experiences a force of what? So basically mass is nothing but 150 grams. Let's convert that into SI units. Alright, time 0.1 second, speed, initial velocity is actually 20 meter per second. When he catches the ball, okay, the velocity becomes 0. Next, he is asking about how much force he would experience. Force F is equal to mass into acceleration. This is the force actually exerted by the ball. Okay, now what is the mass of the ball? 0.15. And what is the acceleration? From v is equal to u plus at, I can take this information. A is equal to v minus u by t. What is v here? Final velocity 0. Initial velocity 20 divided by time 0.1. Okay, so now you just cancel this, then you get 1.5 here, 1.5 into minus 20. Okay, it's nothing but 1.5, 20s are nothing but 30, minus 30 newtons. This is the force experienced, this is the force applied by the ball. So basically what is the force experienced by the person? That will be 30 newtons, option B. Alright, next, if the force on a rocket moving with a velocity of 300 meter per second, okay, force F is equal to 210 newtons, sorry, and the velocity of the rocket is actually 300 meter per second. Very good. The rate of combustion of the fuel is asking about at what rate the fuel will be burnt. dm by dt he is asking about. Now let's consider Newton's second law of motion, where velocity is a constant here, so that's why we can take directly F is equal to v dm by dt. Other time anyway will become 0 because velocity is constant. Okay, what is the force here? 210. What is the velocity? 300 meters per second. And what is dm by dt? That is what you need to find. So 0 gets cancelled. 3 tens are 3 sevens are. So dm by dt is nothing but 7 by 10. Can I say that is 0.7 kg per second? Answer C. Next, a bullet is fired from a gun. The force on the bullet is given by F is equal to this much, where F and T are in SI units, and the force on the bullet becomes 0 as soon as it leaves the barrel. What is the average impulse imparted to the bullet? So he is asking about average impulse. So for finding it out, you can say impulse is nothing but F into force into time. But here force is a variable, so I can take integral F dt. Okay. Now what is F here? 600 into 10 power 2 into 10 power 5 t integral dt. Okay, if I integrate this guy, I'll get 600 into t. I mean integral dt is nothing but t minus 2 into 10 power 5 t integration t square by 2, limits are 0 to some time. We don't know the time, actually time information has not been given, but let us we can find the time using this information. Force on the bullet becomes 0. Let us say at time t it has become 0. Okay, what has become 0? Force becomes 0. So let us equate that force to 0, then we get time information. 600 is equal to 2 into 10 power 5 times t. Okay, now 2 ones are 2, 300s are. So t is equal to 300 into 10 power minus 5. If it goes to the other side, that is nothing but 3 into 10 power minus 3 seconds. Or I can say in 3 milliseconds, the bullet becomes, and the force on the bullet becomes 0. Let me substitute upper limit as 3 into 10 power minus 3. Very good. 600. What is the time here? Alright, minus these 2, that 2 gets cancelled. T square means 9 into 10 power minus 6 into 10 power 5 is already there. If I substitute the lower limit, it doesn't make any sense because even in both the terms you have a time information. So if you substitute t is equal to 0, you get 0 anyway. So 600 into 3 is nothing but 1800. 1800 into 10 power minus 3, 1.8. This is the 9 into 10 power minus 6 minus 5 plus 5 minus 1. So 9 into 10 power minus 9. So 9 into 10 power minus 1 is nothing but 0.9. So it is nothing but 0.9 Newton second. This is the average impulse imparted to the bullet. Alright? Yes. Now let us take the next question. A 500 kg rocket is set for the vertical firing. Okay. So let's consider there is a rocket. The rocket is actually set up for, set already for firing, vertical firing. Okay. What is the mass here? 5000 kg. Now it has to, the exhaust speed is nothing but 800 meter per second. Now to give an initial upward acceleration, you want to give an acceleration A, which is equal to 20 meter per second square, and already there is a G is equal to, let us say, 10 meter per second square. Alright, now what will be the question is the amount of gas ejected per second. He is asking about dm by dt, isn't it? Yes, dm by dt. To supply the needed thrust will be, so upward thrust or thrust required is equal to mass times g effective. What is g effective here? If g and acceleration are in the opposite direction, then you can say the thrust which is going to be acted on this rocket is nothing but m into g plus a. What is the mass here? 5000 into what is g value? 10, and acceleration 30. And now that can be equated to this is actually the net force acting on system, isn't it? So can I say that is equal to dp by dt? So here the velocity is actually constant. Velocity of the exhaust speed is constant. So you can say dv by dt term is going to become 0. You are going to have v dm by dt alone. Okay, it is nothing but what is the velocity here? 800 into V dm by dt, that's what you need to find. So here 2 zeros, here 2 zeros gets cancelled. Okay, next 4, when 2 4s are 2 25s are, okay, 25 into, this is 21, you know, yeah, acceleration has been given as 20 only. So 10 plus 20, 30, okay, we just multiply with 4 here. No, sir, not multiplied, divided by 4, okay, is equal to dm by dt. So if we just cancel this, so basically here 4 ones are 415, 415s are, alright. So now 15, 25s are nothing but oh, it's by 2 also will be there. So if you just calculate this dm by dt, which is nothing but 187.5 kg per second. Which option is correct here? Option B. Clear now? Yes. Next, a force of 6 newtons acts on a body at rest. Okay, when when the body is at rest, the force of 6 newtons is being acted, and of mass 1 kg. Okay, during this time, the body attains a velocity of 30 meter per second. The time for which the force acts on the body is, you need to find the time for which the force acts on the body. Okay, what is the force? 6 newtons. Initial velocity 0. Rest now. Mass 1 kg. What else is given? During this time, the body attains velocity. Final velocity is what? 30 meter per second. Next, the time for which the force acts on the body is. You know, F is equal to mass times acceleration. Acceleration can I write as V minus U by T. Okay, I want to find T. So T is equal to M by F into V minus U. What is M here? 1. Force 6 newtons. Final velocity 30. Initial velocity 0. So it's nothing but 30 by 6. 6 ones are 6 5s are. 6 5s are 30. So T should be equal to 5 seconds. Answer is B. For 5 seconds, this much of force will be acting on the body. Alright. Next, a 10 Newton force is applied on a body, producing it an acceleration of 1 meter per second square. The mass of the body is, so force is given. Okay, acceleration 1 meter square. Okay, now mass of the body. What is the mass of the body? Mass m is equal to force by acceleration 10 by 1. So 10 kg should be the mass. Okay, very easy question, no? Yes, actually a force, this question we have done it already. Okay, it was already came in 2009. We have discussed that question already. The answer was 10 root 2 kg. You can go back and check it if you want. Okay, next. In a rocket, fuel burns at the rate of 1 kg per second. That means what? dm by dt has been given. What is that? 1 kg per second. This fuel is ejected from the rocket with a velocity of, so it's actually velocity of the fuel which is coming out or ejected is nothing but 60 kilometer per second. Alright. Next, this exerts a force on the rocket equal to, so here the force F is equal to V dm by dt. Other term will become 0 because velocity is a constant here. Okay, what is V? V is nothing but at the velocity 60 km per hour into dm by dt is what? 1 kg. So 60 newtons is the answer, isn't it? Yes. No. Actually, see, you have to be very careful. Just to confuse you, he has given this question. 1 kg per second is a SI unit. Okay, fine. But what about kilometer? Kilometer is not a SI unit, no? So you have to convert this into 60 into 10 power 3 meter per second, or 60,000. So you're going to have an extra 1000 here. So into 10 power 3. Okay, that will come out to be 60,000 newtons. Okay, which option is correct now? Option B. Why again? So basically initial velocity is 60 km per second. That means 60 into 10 power 3 meter per second. That is the velocity. And dm by dt is nothing but 1 kg per second. So 60 into 10 power 3 is nothing but 60,000 newtons. Alright. Option B is correct, not C. Be very careful about that kind of questions. A satellite in force free space, okay, sweeps a stationary interdisciplinary dust at a rate of dm by dt. dm by dt is equal to alpha v. Very good. Where m is the mass and v is the speed of the satellite, and alpha is a constant. Okay, the acceleration of the satellite is. So generally, so basically the acceleration of the satellite is going to be here. It is going to be retarded because of this dust. Okay. So now the retarding force is nothing but a rate of change of momentum. Okay, what is rate of change of momentum here? V into dm by dt, because m dv by dt is already 0, because it is constantly sweeping. Okay, velocity has to be constant, speed is constant, so that's why the other term will be 0. So here, since it is a retarding force, you can get a minus here, minus v. dm by dt is nothing but alpha v already. Yes, minus alpha into v square, that is the retarding force, or you can say this is the force of satellite. Okay, now you want to find the acceleration. A is equal to the retarding force divided by mass. Okay, it's nothing but a minus alpha v square by, what is the mass of the candidate? Yes, m. Okay, minus alpha v square by capital M, that is the correct answer. Clear? Yes. Now let us take the question number 16. A particle of mass m is moving with uniform velocity v1. It is given in impulse. Because of this impulse, this particle is getting the velocity from v1 to v2. The impulse is equal to, basically impulse is nothing but a rate of change of momentum. It's a vector quantity. Okay. Final momentum minus initial momentum. What is final momentum here? mv2. Initial momentum mv1. Okay, since it is a vector quantity, you can see both a and b are looking like same, but it's a vector quantity, so you cannot leave the answer in terms of magnitude. So it's better to leave it like this. Okay, since v2 and v1 are velocities or the speeds, so you can leave the answer in terms of this. That is most appropriate. Option D. Next, a 600 kg rocket is set for a vertical firing. Let me drink some water. So a 600 kg rocket is set for a vertical firing. Okay, so we have done this kind of problems already, similar kind of problems. Okay, so mass is 600 kg. Alright, is set for vertical firing. If the exhaust speed 1000 meter per second. Now the mass of the gas ejected per second to supply the thrust needed to overcome the weight of the rocket. So basically here, the force required or the thrust required to overcome the weight of the body is nothing but let us say F, that is equal to mg. Okay, what is that? That has to be equal to rate of change of momentum. Okay, so d by dt of momentum is equal to v m into v. Okay, now again he has given the velocity is constant, so one term only will be remaining, that is v dm by dt. Other term is going to become 0. Very good. What is the mass here? Mass 600 kg. G value, let us take it as 10. Okay, and now he is asking about dm by dt, mass of the gas ejected per second. So that is dm by dt is equal to 600 into 10, 6000 divided by what is the velocity? Velocity is actually 1000. Okay, so this is nothing but 6 kg per second. That is going to be the answer. Alright, next, a rigid ball of mass m strikes a rigid ball of 60 degrees, okay, like this, and gets reflected without loss of speed. Okay, speed is the same, v and v. The value of impulse imparted by the wall on the ball will be. So now he is asking about impulse imparted, that is equal to final momentum minus initial momentum, or you can say change in momentum. Okay, let us find out what is p1 and what is p2. For that, let us take a bigger diagram of it. Okay, now if you see, for finding out v2, I need to find velocity. Can I say this is m into v2 minus v1? Yes, I can. So here initial velocity is nothing but v, and that is going to have two components. One is horizontal velocity, other one is vertical velocity. Horizontally and vertically. So if this is 60, this is also 60, corresponding angles. Okay. Velocity, what will be the velocity here now? V cos 60. What will be this velocity? V sin 60. Similarly, what will be this velocity now? And this velocity now. So this is 60, so this will also be 60. Same angles, na? So here, this will be V cos 60. This will be V sin 60. Okay. So now, what is initial velocity? V1 is equal to V cos 60 I cap minus V sin 60 J cap. Okay. Next, let me rewrite this as V cos 60. Cos 60 is nothing but 1 by 2 V by 2 I cap minus V sin 60 is nothing but root 3 by 2 J cap. So you can take V by 2 common, I cap minus root 3 J cap. Alright. Next, V2. What is V2 here? V2 is going to have V1, V cos 60 minus I cap. Okay. Minus, and this one is going to be already the negative component. Okay. So V plus V sin 60. It is also along the negative axis, which is y axis. Okay, negative y axis minus j. So now let us try to find mv2 minus v1. So cos 60 is what now? 1 by 2. Sin 60 root 3 by 2. Let me take v by 2 common. That is going to be minus I cap sin 60 minus root 3 j cap. Alright. Now if you just take both these difference between v2 minus v1 multiplied by m is nothing but you are going to have, see, v2 minus v1. So you are going to have these terms only. These terms are going to be cancelled because this is minus here, that becomes plus there because of minus v1. Okay. So I am going to consider the second term. I will consider only the first term, v by 2 into v by 2 minus I cap. What is the v1? v1 is again minus I cap now, since you have taken v by 2 common. mv by 2 I cap minus I cap into minus I cap minus 2 I cap. These two, that 2 gets cancelled. So the net impulse is nothing but mv along the negative x axis. Clear? Yes. Option A is correct. Next, a body of mass m hits normally a rigid wall with velocity v, bounce back with the same velocity. The impulse experienced by the body is, so basically normal hit, no? So let us say this is the wall, and now you are taking a ball of mass m, it is going to hit the wall perpendicularly, or you can say normally, and it has to come back with a he said that the reverse back ball will be having the same velocity v, initially v, finally v. So now initial momentum pi is equal to mass times initial velocity v. Okay, final velocity pf is equal to mass times velocity is along the negative x axis, isn't it? Minus v. Okay, so now what is impulse, amma? Impulse is equal to final momentum minus initial momentum. What is final momentum? Minus mv, initial momentum plus mv. So it's nothing but minus 2 mv bar, or you can say minus 2 mv, or if you want to find only the magnitude, it will be plus 2 mv, because minus is not there in any of the options. Next, a 0.5 kg ball moving with a speed of 12 meter per second strikes a hard wall at an angle of 30 degrees with the wall. It is reflected with the same speed at a same angle. So basically he has given, let us say here, this is the wall, hard wall, rigid ball, whatever, and this is a normal. So the balls are being projected at an angle of 30 degrees, and the mass is actually 0.5 kg. Initial velocity 12 meter per second, and now yes, if this is 30, he said that it will also bounce back with the same angle 30 degrees. Alright, it is reflected with the same speed at an angle at the same angle, so both of them are given as the same. Fine. Now if the wall is in contact with the wall of wall for 0.25 seconds, time duration is 0.25 seconds. Okay, the average force acting on the wall is, so what is the average force acting on the wall? That is nothing but delta P by delta T. Okay, final momentum minus initial momentum. I can say that mv final minus v initial divided by the time duration 0.25 seconds. Okay, and now you need to find vf vi. So here again you'll have two velocities, one in this direction, other one in this direction, and here also you'll have two velocities, one in this direction, other one in the opposite direction. Okay. So here this is going to be this is 30, this is 30 corresponding angles, v cos 30, this is a v sin 30. Here also if this is theta, this will also be theta or 30. You can say that this is a v cos v cos 30. Okay, what about this here? This angle is 30. Shit. Wait. This is going to be cos 30. This is also going to be sin 30 now. Okay. Now this is v sin 30. So you are going to have these two components are in the same direction. When you are taking this component and this component are going in the negative y direction. When you are taking the difference now, then both of them will cancel each other. Then you are left with only this sin term. So can I say that is m into 2v sin 30? Of course it will be minus, but I am not considering that minus anymore. 0.25, can I write it as 1 by 4? Yes. What is the mass here? Mass 0.5 kg into 2. What is the velocity? 12 meter per second. What is the sin 30? Sin 30 is equal to 1 by 2 divided by 1 by 4. So can I write this as 0.5 kg as 1 by 2 kg? 1 by 2 is nothing but 1 by 4. That is going to cancel with 1 by 4. 12 2s are 24 newtons. That is the amount of average force is going to be acted at the wall, on the wall. Clear? Yes. Now the last question in this: a body of mass 3 kg hits a wall at an angle of 60 degrees. Okay, similar to the question, similar to the previous question where you have got 60 in the place of 30. That's it now. Now the impact time was 0.2 seconds, and the angle is 60 degrees now. And now what is the force exerted on the wall? Okay, that force is equal to, you can say that delta P by delta T. So it's nothing but mv2 minus 1 divided by the time duration t. Okay, v2 minus v1. In the same kind of case, you're going to have m into 2v sin 60. These are the components which will be surviving. Remaining all the components will be cancelling each other divided by time. What is the mass here? 3 kg. Velocity. Velocity is actually given here 10 meter per second. Okay, sin 60 is nothing but root 3 by 2 divided by the time is 0.2. Okay, so these two gets cancelled. This 2 becomes 0.2 becomes 2 divided by 10. Okay, 2 ones are 2 fives are. Okay, 3 fives are 15. 15 tens are 150. 150 root 3 is going to be the average force. Newtons is going to be the average force acting on the system. Option A is correct. Clear? Now, thank you very much for your kind attention, and let us see the remaining questions in the other parts of the video. Okay. So, if you like the video, please do comment in the below, and if you feel that it's very much useful, you can share it to your friends, and please do not forget to subscribe. Thank you very much once again. See you once again in the next video.